right, hi everyone. Uh, this is Artie, the anteater. He's our special guest today. I know everyone's anticipating the big show with Lady London Sprinkles, but she's not here right now, and obviously she's too busy for me. So we got Artie here, and he's here to help us talk about weather. So for this lesson, I need you guys to have your workbooks and access to Amplify's weather and weather pattern simulator. Before you start, all right, guys. So on page 6, it shows you this image presented here on the screen, and it shows the water cycle. I want you guys to take some time to think about what this image is showing and what information you already know from past units in your elementary school grades. And what do you know about this image, and what can you kind of infer if you've never even seen this before? At this time, you could press pause and to take time to answer on page 6. All right, so welcome back. So if you knew this was the water cycle, great. If you didn't, that's okay. We're going to be working on the basic water system as well as adding some parts that you may not have heard before. Sorry. So as you can see on the screen, the image shows some type of water going up and then over into this cloud, and then again water coming down. This is a very basic model of the water system, and it's showing the evaporation of water, the condensation of water, and the precipitation of water. All right, so this is our new unit, weather patterns. During this unit, we're going to be talking about different things about weather. At this time, I would like you guys to think, before we even get started, what is weather? How would you write the definition of weather? All right, so the definition of weather is the conditions such as rain, clouds, and wind at a particular time and place. Right here is a very important part where it says particular time and place. When we talk about weather, we're talking about the conditions of where we're located or where an event is located. We want to make sure we're also talking about the time. So when things are occurring at the current time, but also when we talk about over time. Right here I have the definition written in Spanish, and I want you to notice this important word right here. Clima. Or clima. I'm not sure how it's pronounced. But this is the root word for a common word that we use when we talk about weather in the news. And when we talk about global warming, we kind of shifted from global warming to climate change. And right here is the root word for the word climate change. And what it really means is the change in weather. When we talk about change in weather, we're talking about how has it in the past at a time changed in a particular place. So in the past, how was weather, to a current time, how is weather at a particular place. So when we're talking about weather, make sure that you understand that we're talking about a particular time and place. The next thing we're going to do is watch a video. You're going to have to access this video on Amplify, and I'm going to show the directions on how to get to the video right after this. If you are trying to get to the video, you're going to want to click on Weather Patterns, Chapter 1, Understanding Rain Clouds, Welcome to the Weather Pattern Unit, and right here, if you click here, you'll get to the video. You just press download. You may not even have to download, and you press play. So any questions about how to get onto the video, please remember that you can absolutely just send me a message and I will get you started on the video. So all right, guys, welcome back. All right, so as you can see here, we have some boiling water. You guys have, I messed this up. Sorry, guys, I messed this up. We're gonna start from the beginning. Welcome back. All right, so we have a standard pot of boiling water, and we're gonna talk about what parts of the water cycle this can be part of. The boiling water, as it heats up, begins to evaporate. But where does the water go once it's in the air? This is the time for you to take your guesses. All right, so if you don't know where it goes, that's okay. But we're gonna try to figure out where it goes, because we know it cannot be created and it cannot be destroyed. So as the water goes from liquid into a gas, we call that evaporation. This evaporated water is what we call water vapor. But as the water rises, it leaves our temperatured air here on the surface and rises through the troposphere into the colder air. The higher you go in our atmosphere, the colder the air gets. We know that as things get colder, they go back into solid form. So it goes from being a liquid here, steaming, to water vapor, becoming a gas, but eventually it hits colder areas where it then has to come back into being a liquid. So if I hold this mirror here, above the water vapor, which is much colder than the pot, we see that it starts to form this residue. You might recognize this from when you take a shower or when you're in your parents' car and they tell you not to draw any smiley faces on the windows. But as you draw those smiley faces, you start to realize that there's water. That's because as the water goes from the gas to the colder part where it comes back to liquid, it starts to condense, and we call that condensation, which becomes a cloud. Hope you enjoyed my little demonstration. But now that you watched the video and some information about clouds and how they form, we have the situations going on in Galetown. Right now we have 3 claims. Claim 1 is that the lake was built near Galetown, caused it to have more severe rainstorms. And when we say severe, we're talking about the idea of more extreme, more violent. Another claim that might explain what caused the more severe rainstorms was that the warmer weather caused Galetown to have more severe rainstorms. So this one is kind of similar to what we hear in the news a lot when we talk about climate change. We talk a lot about the warmer weather around the world. So I want to keep an eye on this one, as it kind of plays a lot into our current situation around the world. And then we have claim 3, which talks about the stronger winds in Galetown. This wasn't mentioned in the video so much, but we wanted to keep an eye on this one because it talks about not necessarily the amount of water, but the conditions around. And when we talk about weather, we have to remember it's the conditions at a certain time or place. So all 3 of these claims have some plausible reasons why it could be the reason why Galetown is having some more severe storms. But we're going to continue on with this unit to kind of narrow it down to the one that fits best with the situation in this town. Here are the claims in Spanish. If you're a Spanish speaker, this might be a good time to press pause to read through these. So in the demonstration I showed you, we have the evaporation idea. So the idea is that the sun heats up the water enough that the water gets warm enough to evaporate and go from a liquid state into a gas state. So this requires thermal energy, so some type of heat. Um, so as it goes from evaporation, it goes into the water vapor. So the gas stage of water is called water vapor. If we go back to our map here, or to our diagram, you see that we have the idea that the water is going, sorry, let me find my little, I don't know where my mouse went. But as you see, it goes from the lake or some type of large body of water, and it rises up. So this idea of going from a liquid to the gas, entering the atmosphere. All right. So then we have the idea of condensation. Condensation is when the gas goes back to a liquid. And as you go through the atmosphere, it gets colder. The higher in the troposphere you are, the colder it really is. So when things get colder, they tend to get closer together, getting more solid. So as it gets colder, it forms back into the liquid state, sometimes even in a solid state, and the condensation is what forms that cloud. So some people during the class lesson mentioned that the water goes into the cloud, when in fact it doesn't go into the cloud. What it is it forms the cloud. A key difference of the terminology. So make sure you're really understanding that the cloud is made from the water that was from the ground. We're going to do a simulation on the Amplified Weather Patterns simulator. At this time, you can switch over to the simulator while you watch this video. You're welcome to either read the directions on page 7 and complete the experiment on your own. And if you don't have access to the simulator, you're welcome to follow along in the video where I show you guys the steps to go on with. I complete the experiment on screen. You're welcome to do either or, but make sure you have the data table filled out. So to get to the weather sim, you're going to want to click on these 3 lines again up here and click on weather sims. Yours looks a little different than mine, but it should be the last one that you have. When you get to this page, click again on the 3 lines and go to regional weather number 1. I ask that you stop this video and actually play around for a few minutes on this simulator to get used to some of the functions that it has. All right, so if you are back or you don't really care to play around with this simulator, we're going to start the experiment. So before we begin, we have to choose a level for the sun. And we are going to keep the level of the sun the same throughout the entire experiment because it's going to be our constant. It's not going to change at all. I'm going to leave it on level 5 just because I like to see the dramatic effects. And it wants us to compare 2 different surface water levels, which you could actually debate on whether it's similar to the lake or not in Galetown. So before we begin, I'm going to drop down to 0 surface water, which would be similar to before they entered and put the lake in. I'm going to press run, and I'm going to watch what happens. there's still rain, which we'll talk about other sources of water besides lakes and lakes and oceans. We can see here that there is definitely some type of river, but we're going to talk about the overall ways that water enters our system. For this experiment, you're going to have to press the Analyze button and go back to where it says condensation. Because we're looking at the point before it begins raining. So on here we have evaporation, when the sun is heating up the water enough to turn it from liquid to gas. But we're really concerned about this point right here, the condensation, which would indicate how much of the water is in the sky. Some key notes that I want you to pay attention to are the temperature readings. As you see, again, as we're lower to the surface, it's warmer. And as it goes through the troposphere, the temperature begins to get colder. So here, as it's rising, it starts to get colder. You can see in the temperature area right here, as it gets to condensation, it gets cold. All right, so let's stay at this condensation point. So when we had 0 surface water, our water vapor at condensation is 16 kilograms. Now, you're going to enter that data on the first trial of the activity. We're going to go back and change only the surface level. I am not changing the sun again because that is a constant. So we're going to go to the surface water and change it all the way to 5 because I like to see the dramatic differences. I'm going to click Run. This large amount of water would indicate similarities to adding a lake or a dam to a neighborhood. We can see that there's definitely much more rain here, but we're not actually looking for that. We're looking for the water vapor. Again, we're going to go to the Analyzing tool, go back to when there was condensation, and look at the water vapor levels. This is 50, which is more than double the original without any surface water. So this idea kind of supports claim 1, with the lake being part of the effect. But we didn't change any other conditions or kept water a constant. So we're going to have to explore more to see what claim we can actually eliminate to keep going. So I want you to answer the question on the bottom of page 7. And I want you to take some time to pause and think about this. You're also welcome to come back and play with with different variables. And if you're really inclined, you're welcome to look at the different options we have in this simulator. Now that we've finished the simulator and the demonstration, you have enough information to finish your homework, which is pages 8 and 9. And on Monday, I'm going to be checking all the pages, 7, the table and the question, and the 2 homework pages, 8 and 9. I'm also going to send out the reading. It's not due Monday, but it is due Tuesday, and there's going to be some work to go along with it. It might be a good idea to spend some time this weekend going over the article and make sure you have the work done by Monday so that you can get the credit for it.